You probably think the moon is still there, even when you turn your back on it and walk away. But according to the most successful branch of science we have, you might be totally wrong about that. There is a discovery in physics that is so strange it makes horror movies look like bedtime stories. It suggests that nothing in our world is actually real until someone or something decides to look at it. For hundreds of years, we believed the universe was like a giant mechanical clock that just kept ticking. Scientists like Isaac Newton told us that if we knew where everything was, we could predict the future. This is what we call classical physics, and it makes us feel very safe and very sure of ourselves. In this old view, the world is objective, meaning it exists perfectly fine without us being here. If a tree falls in the woods and nobody is there to hear it, it still makes a sound. The rocks, the stars, and the chair you are sitting on are supposed to be solid and permanent. Scientists were just the observers, standing on the outside and looking in through a glass window. They thought they were discovering a truth that was already written in stone. But about 100 years ago, a group of scientists started looking at the very small stuff. They looked at atoms and the tiny particles that make up everything we see. What they found shattered every rule we ever thought we knew about how reality works. It all started with a simple test called the double-slit experiment, which changed human history forever. Imagine you have a wall with two vertical slits cut into it, and you throw small balls at it. Most balls would hit the wall, but some would go through the slits and hit the screen behind it. You would see two vertical lines on that back screen where the balls landed. This is exactly how we expect solid objects to behave in our everyday world. Now, imagine doing the same thing, but with waves of water instead of solid balls. The waves go through both slits at the same time and ripple out on the other side. When those ripples meet, they interfere with each other and create a pattern of many lines. This is called an interference pattern, and it is the signature mark of a wave. In the early days of physics, we thought light was just a wave because it made these patterns. But then scientists decided to try this experiment with electrons, which are tiny bits of matter. They expected the electrons to act like tiny little paintballs and leave two lines on the screen. Instead, the electrons created the many-lined pattern, just like a wave of water would do. This meant that matter, the stuff we are made of, can act like a wave and a particle. The scientists were confused, so they decided to get a closer look at what was happening. They placed a tiny measuring device near the slits to see which hole the electron actually went through. They wanted to catch the electron in the act of being in two places at once. But as soon as they started watching, the universe did something absolutely terrifying. Physicists call this a wave function, which is basically a giant cloud of mathematical possibilities. The particle is here, it is there, and it is everywhere in between, all at once. But the moment we measure it or look at it, that cloud of possibilities collapses instantly. Nature is forced to pick a single spot and stay there just because we decided to pay attention. This means that at the most basic level, reality is not solid or fixed until it is observed. Think about what that actually means for the world around you and the people in it. If the things that make up your body are only waves of probability, what are you when nobody looks? This discovery led to the Copenhagen interpretation, which is the standard way we understand physics today. It says that physical systems simply do not have definite properties before they are measured. This scared Albert Einstein so much that he spent the rest of his life trying to prove it was wrong. He famously asked if the moon only exists when a mouse looks at it, hoping to show how silly it was. But as the years went by, every experiment we ran showed that the silly idea was actually true. The scary part gets even deeper when we start talking about how this affects time and cause. A famous physicist named John Wheeler came up with an experiment that sounds like science fiction. He suggested that we could choose to look at a particle long after it had already passed the slits. According to his theory, our choice in the present could change how the particle acted in the past. This is called the delayed choice experiment, and it has actually been performed in modern labs. The results were shocking because they showed that now can literally rewrite then. When we measure the path of a particle today, it changes what that particle did yesterday. This breaks our linear understanding of time, where one thing leads to another in a straight line. It suggests that the universe is not a movie that is already recorded and playing back. Instead, it is more like a live performance where the script is being written as we watch it. There is another experiment called the quantum eraser that makes things even more bizarre. Scientists found that if they gathered information about a particle but then erased that information, the wave pattern came back. If the knowledge of where the particle was is gone, the particle goes back to being a wave. This implies that reality is built on information rather than solid physical matter. It's almost as if the universe is a giant computer simulation that only renders the details we need. Einstein hated this idea because it meant the world was fundamentally unpredictable and ghostly. He called quantum entanglement spooky action at a distance because particles can stay connected. If you have two entangled particles and you look at one, the other one reacts instantly. It doesn't matter if the second particle is in the next room or on the other side of the galaxy. They are linked across space and time in a way that defies everything we know about speed limits. For a long time, people thought there might be hidden variables that we just didn't see. Einstein thought that maybe the particles had a secret plan or a hidden code telling them what to do. But in 1964, a man named John Bell came up with a mathematical way to test this idea. Decades later, experiments proved that Bell was right and Einstein was wrong about this one. There are no hidden variables and there is no secret code sitting under the surface. Reality is truly and fundamentally undecided until the very moment a measurement happens. This has completely changed the way the scientific method works in the modern era. We used to think we could be objective observers who didn't affect the things we studied. Now we have to admit that the scientist is a part of the experiment itself. We are not just finding the truth, we are participating in the creation of that truth. This leads to a massive problem called the measurement problem that still haunts physics. What exactly counts as an observer that can make the universe become real? Does it have to be a human being with a brain and a soul to make the wave collapse? Or can a simple camera or a single atom acting as a detector do the job just as well? Some scientists believe that consciousness is the key ingredient that makes the world solid. They argue that without a mind to perceive it, the universe would just be a giant soup of waves. This would mean that we are not just living in the universe, but we are actually making it exist. Other scientists think this is going too far, and that any interaction with the environment is enough. But even then, they can't explain where the line is between the quantum world and our world. Why do atoms act like ghosts, while a chair feels like a solid, unmoving object? This tension is perfectly captured by the famous story of Schrödinger's cat in a box. In the story, a cat is trapped in a box with a device that might kill it based on a quantum event. Until you open the lid and look inside, the cat is technically both alive and dead at the same time. It sounds like a joke, but it is a perfect metaphor for the scary reality of our universe. We live in a world that is made of things that are not actually things until they are witnessed. This has led to a growing school of thought called scientific anti-realism. It suggests that our scientific theories don't actually describe the objective world. Instead, they only describe the rules of how we experience the world through our senses. Our eyes and ears might just be a user interface, like the icons on a computer screen. When you click a folder on your laptop, you aren't actually touching a blue square. You are interacting with a complex layer of code and electricity that is hidden from you. The real world might be something so different that we can't even imagine what it looks like. John Wheeler called this the participatory universe, where we are all co-creators. He believed that every time we ask a question of nature, we are helping to build the answer. This shifts the goal of science from discovery to a form of active interaction. It means that the universe is not a finished product that was handed to us. It is an ongoing event that requires our presence to continue functioning as it does. Today, this discovery is leading us toward things like quantum computing and new technology. We are learning how to use these ghostly properties to build machines that are incredibly fast. But as we build this tech, the philosophical mystery only grows larger and more intense. We are still searching for a theory of everything that can bridge this weird gap. We need to know why the small world is so fluid, while our big world feels so rigid. Some think that gravity might be the thing that forces reality to stay put. Others think that there are many worlds, and every time a choice is made, the universe splits. In that view, every possibility actually happens, but in a different branch of reality. But regardless of which theory is right, the central discovery remains just as scary. The foundation of our existence is not as solid as we were taught in grade school. The ground beneath your feet is only there because your body is interacting with it right now. The stars above your head are only burning because their light has found an eye to hit. The more we look into the heart of matter, the more it seems to disappear into thin air. We are realizing that the universe is not a collection of objects, but a series of connections. It is a beautiful, terrifying, and mysterious dance that requires an audience to happen. We used to think we were small and insignificant dots in a massive, cold machine. Now, we know that we might be the very thing that keeps the whole machine running. Science has moved from the cold certainty of the past to a humble state of wonder. The greatest discovery in physics is that we are not just guests in this reality. We are the reason there is a reality to speak of in the first place. If you want to see how this discovery is being used to build the future, watch this next video.